I got it. Just recording all my classes today. Okay. So, yeah, if we scroll all the way down, we don't have that one. That will be the start of Cal 2. Yeah, we used to get through substitution and then they covered as a review at the start of Cal 2, but yeah. It's basically like if you think about how we did the chain rule, the integration by substitution is doing the chain rule backwards. Meaning when you look at an integral, if you're like, this is really ugly, look at the ugliest part and think, if I took the derivative, what would the extra parts be from the chain rule? Do I see those extra parts? Then I just have to find the right u and I've got my integral. Like it sounds weirder than it is. All right, so we have restructured this question. Instead of tell us everything you can about a point, we gave you a bigger graph with more points that are doing interesting things. But we asked like a question and then asked it about particular x values. Because there's not really a point in asking if these discontinuity points are maxes or mins. Like, that's not the point of them. So we split it up a little better on the exam. So instead it'll be like, are these points continuous or not? If they're discontinuous, tell me if it's a jump, removable, or infinite discontinuity. So we give you the words. You don't have to remember the words. You just got to remember which one means which. But we added more questions in here because we split it up like that. So there's also like, all right, what's the derivative at each of these points? Meaning not like what is the actual number, because you couldn't tell me what the number derivative was here at -4, but you could tell me the derivative at -4 is positive. Number, whatever it is positive. Or if I was here at a low point, oh, that derivative 0. Over here, that derivative doesn't exist. Of course, that one doesn't exist because it's not even continuous. You have to have continuity to be differentiable. So expect a graph with more questions, but they're more focused. So you're not having to like think, okay, x equals -6. Which of these is it? It'll be a little more focused. But I mean, if we look at x equals -6, that is a local minimum. And the concavity there would be concave up. The derivative there is 0. And it's continuous, so we don't have to, like, it doesn't match any of the discontinuity stuff. All right, the next point was x equals 2. So at x equals 2, it is discontinuous. Those two sides do not meet. And it is a jump discontinuity because there's an actual difference between the limits from either direction. So all right, so a jump discontinuity. Limit as x approaches 2 from the left is 8. The limit as x approaches 2 from the right is 5. So the fact that those are not the same number is what tells you it's a jump discontinuity. I don't remember if we actually asked one-sided limits or if we just asked if a limit existed or not. But for x equals 2, the limit does not exist. For x equals 4, which is the fourth one down here, the limit does exist because the left and the right side are both approaching that value. It's not differentiable because the value doesn't fill in the point, but the limit does exist. Mhm. That's our removable discontinuity. The limit as x approaches 4 of our graph is 3. And then x equals -1 here is right here. Zoom in. That is an inflection point. So the derivative there is 0. That's a concavity change where it flattens out. There is actually an inflection point somewhere here between -6 and -1. It probably is -4, but we're not going to ask you to pick that kind of inflection point. It's actually kind of hard to tell like where it's changing from positive concavity to the negative concavity we see up here. But this kind of flatten out point, the more classic inflection point, yeah. All right. So questions on that, the kind of information I was going over, the limits, differentiability. They can look different. Like that's what I was saying around -4 here. Like we have a positive concave left and then up into -1, like it's negative, but saying where exactly the concavity changes looking at the graph is kind of difficult. Because like it might be -4, but it might be -4.14 or it's somewhere in there. So we're not going to ask you to pick out this kind of inflection point where it's hard to tell, but the one where it flattens out, yes, that's what I call a classic inflection point. It's just, it's kind of weird because the ones that flatten out, that's where the first derivative is 0 and then the second derivative is also 0. Whereas that -4 number, the first derivative won't be 0 there, so it's not a critical value for the first derivative test, but it will show up in the second derivative. And now we got some limits. So this is a free-for-all, any which way you want to solve it. So you're welcome to use L'Hopital's rule if it applies, but you can use other methods as well. So the big thing about L'Hopital is to use it, you have to get 0 over 0 or infinity over infinity. If you don't have that from plugging in the value, then you have to do something else. L'Hopital does not work on that form as it is. Now, we're not going to give you all the fractions that you got to put together like we did on the last test. We didn't do that. But just pay attention. Like some of them, you may only need to do L'Hopital once, and then you can algebraically transform it and go from there. Others, you can do L'Hopital a whole bunch of times. Like if we look here at B, I'm just gonna rewrite the order. So this is one of the like subtle tricksy things we do is we're not putting the polynomials in descending order, which is standard order. So if you're not paying attention, you can think this is 2x cubed over 2x to the fifth. The bottom grows bigger, so the limit should go to 0 as x goes to infinity. When you rewrite it in descending order, then you're actually seeing, oh, these are both fifth powers. So this limit as it goes to infinity is going to end up at 3/2. So we can do L'Hopital, but you're going to have to do it 6 times. Or, well, no. 5 times? You have to do it until all the other terms cancel out. Like derivatives become 0, then you can finally reduce the last bit and get the answer. But when you see ones like this, what I would recommend instead is I would multiply everything by 1 over x to the fifth over 1 over x to the fifth. Because writing out L'Hopital 4 or 5 times is too much. So this will become 3 plus 2x cubed over x to the fifth is going to leave us 2 over x squared plus 5 over x to the fifth. And then on the bottom, we would have 2 plus 7 over x to the fifth. Then the other piece of information you have to remember is that the limit of a constant over infinity goes to 0. So when I plug in the infinities here, 2 over x squared, that'll go to 0. 5 over x to the fifth will go to 0. 7 over x to the fifth will go to 0. So when we do the limit as x approaches infinity of this, it's just going to go to 3 plus 0 over 2 plus 0. So the limit actually will equal 3/2, and you didn't have to do 4 to 5 L'Hopital's rules to get there. C is another kind of deliberately miswritten. The 6x to the fourth is the highest power term on the bottom. The 4x cubed is the higher power term on top. So here the bottom is growing faster than the top. So this one like reduces to whatever the limit of 4x to the third over 6x to the fourth is, which here I can cancel most of those x's out, so it's the same as the limit of 4 over 6x, which gives us our same constant over infinity, so it goes to 0. Now, just to be very clear, if we get the flip, the limit of infinity over a constant, that is infinity. Half of infinity is still infinite. First one, uglier, but it is also a L'Hopital. So if I plug in 0 here, 2 times the sine of 0 over e to the 0 minus 1. Sine of 0 is 0. E to the 0 is 1. So we do get the 0 over 0 we need, so we can use L'Hopital's rule. But I need you to at least write the 0/0 step. Maybe some work in between if it's not immediately obvious to you that it's 0/0. And then when we apply L'Hopital's rule, the way it applies is we do the derivative of the top on its own, the derivative of the bottom on its own, and then we look at the quotient of those. So our top, the derivative of 2 times sine x, will have the 2 still, and that will be cosine x. On the bottom, the derivative of e to the x is e to the x minus 1, that goes to 0. Well, I guess that's better than putting a scheduled test in the middle of finals week. Sorry, those of y'all online, the screen now has this big old banner. This is a scheduled test, the UTSA alert system. That's why my phone was making noise. Thanks. All right, so we've done the derivative of the top, derivative of the bottom. Now we're going to plug in 0 again. So now I have 2 times cosine of 0 over e to the 0. The cosine of 0 is 1. E to the 0 is 1. So that 2 out front actually mattered and is our answer.
So for the limit set infinity,
Mhm.
you look at if it's bottom heavy. Like if it is bottom heavy, you want to look at what like we need to take forward with it. 6x supports there 6x.
So yeah, there I was saying it's approximately equal to this.
So for all that's bottom.
You can do it if they're both, if it's a rational function with just a polynomial on top, polynomial on the bottom. If it's like the first one, think through it differently, but for our polynomial ones, and you're going to see these at the end of Cal 2, that's why we have them on the exam here. Because you have to do limits at infinity a bunch at the end with the sequences and series. All right, number 3 is a bunch of rowdy derivatives. We changed it up, but it's still 3 derivatives. So A here has inverse cosine. On the front of the test, we're going to give you the inverse trig formulas. So you don't have to memorize what the derivative of inverse cosine is. It will be there for you, but only the inverse trig function. So you got to remember how to do product rule and quotient rule yourself. There it is. All right, so the derivative of the inverse cosine of x is -1 over the square root of 1 minus x squared. X can be substituted out for anything else, and we just use the chain rule. So here our x is e to the 4x. So following my formula, -1, big square root over big the square root of 1 minus e to the 4x squared. Sorry. Let me rewind that. So our derivative of inverse cosine of x is the -1 over the square root of 1 minus x squared, but x can be anything we want as long as we follow the chain rule. So that's what this is asking us to do. So the start of it is going to be, we follow the format, -1 over big square root 1 minus, and instead of x, I'm just going to leave a spot, and then we'll have times the derivative of whatever's in the spot. And in this case, our thing is e to the 4x. Now, I would like to point out the other thing it says up here is you do not need to simplify your answers. So we do still need to fill out what the derivative of e to the 4x is, but you don't have to clean it up further than that. So this is more about, I followed the first part. Now let me just write it. So I include my chain rule. And if you do this all in one step, that's fine. This is more about showing me you understand how to read the table, how to use the chain rule. All right, so our derivative of e to the 4x is e to the 4x. And then this actually provokes another chain rule, that 4x. We have to do times the derivative of 4x, which the derivative of 4x is just 4. So I could put the 4 times e to the 4x on top of the big square root, or I can just leave it like this. And like I said, on this one, I would take just that. Like if it makes sense in your brain too, I did the first part, now I'm doing my chain rule times. All right, the derivative of that thing is this times extra chain rule, the extra 4. Because I'm tired. If you forget the negative, I'll only take off a little tiny bit. I don't think we put one of the C's though.
So you don't distribute the square on the denominator?
It wouldn't distribute, it would just multiply to the 4x.
Yes.
So we could write it as the square root of 1 minus e to the 8x, but we don't have to. Like on this page, it's very much show me you understand the derivative rules, and that's it. Don't do any algebra because that's a waste of time. And time is like the most precious commodity on the final. I'm a tiny bit worried about the length, not super, but you definitely got to keep your pace up. And simplifying these is just extra time you don't need to spend. This is easier for me to grade. All right. So apparently in the spring, Chris felt like torturing his students because quotient rule with the trig and the square root is a bit much. But we can still do it. So you got to remember your quotient rule, low, square root of x, d high, derivative of sine is cosine. But this was not just sine of x, this was sine of 5x. So this is also going to get times 5 for our chain rule. So low d high minus high, now our sine of 5x. D low, so the derivative of the square root of x. Remember that's x to the 1/2, so we can write it as 1/2 x to the -1/2 for our derivative. Over square the denominator. And away we go. That's it. Don't get fancy. That is easy to grade for me. So even with the square root of x, like, it's not too bad. It's just a little annoying. All right, and then C down here, we've got a natural log of a natural log of x. So yay for nested crazy functions causing chain rules. But the natural log of x is like your bestest friend in Cal 2. Because it can make what is really disgusting integrals into tedious but a lot more doable integrals. So we got to remember though, what is the derivative of the natural log of x? Yep. So if it's just x, it's 1 over x. If it's some sort of ugly, then it's one over ugly times derivative of ugly with respect to x. And this will actually sometimes get shortened to du over u in Cal 2. No, not sometimes, it does get shortened too. Just because of the way integrals work, you won't have multiple differentials. There. All right, but for ours, so the derivative of this natural log of ugly is 1 over ugly times the derivative of ugly. But our derivative of ugly, natural log x, is just 1 over x. So you could rewrite it as 1 over x ln x if you want, but that's perfectly fine by me. You just got to get to the step where there's no more derivative that needs to be taken. And you don't have to write the in-between step. If you're fine going from here to here, I'm fine grading it like that. So we've got an application of the derivative question here. Which we do still have. All right, we've got the properties of definite integrals where we've defined a couple of integrals for you. You've got to figure out how to work with all the extra numbers in here. Figure out how you can subtract them. You can also flip the bounds. But we did a couple of those on the homework. I'm wanting to make sure we at least talk about everything that's here. So area under a curve. So we're given this crazy function. We take a peek, there's our graph. So understanding that the the integral is a way of saying what's the area under the curve between the numbers. So how can I figure out the answer to this integral without doing calculus? Like the calculus step is knowing that this means all this. But what is this shape that I'm shading in? It's half a circle. Well, how do we find the area of a circle? We look on the front of the test, and the front of the test will have a whole bunch of area formulas, and one of them will be pi r squared. But this is half a circle. So this is here, I'm just gonna put what looks like a donut. So this is the area of a full circle. So our area here is gonna be 1/2 pi r squared. Now, what's our radius? So if I zoom in, these tick marks are by ones. And it is centered at 0, 0. Yep, so it's 5 units out. The area is 1/2 pi times 5 squared. So 25 pi over 2. Why do I know that? Because that graph is half a circle and the radius is 5. That we can see by inspection from the picture. So this is effectively a Cal 2 question. But we just barely got to this, so it's end of Cal 1 question as well. Now, if we didn't know that this square root of number minus x squared produced half of a circle, it would be more problematic. Like then we'd be fully into Cal 2 and arguing with how to crunch this up. Which we sometimes do ask Cal 2 students to do. And it's like, it's a fair question, but it's kind of a dick question because it's like from the very beginning of the course, before you learned any of the fancy integration techniques. So you didn't have a lot to pull from when you saw the problem the first time. When you see it again later, your brain actually has several different ways it'll try to think through it. All right, we do have one of these. So we've got a function. A is asking us to determine the antiderivative, the general antiderivative. You got to remember what that means, what thing you can't forget when you do it. And then the second part gives us bounds to put on the integral, so they actually want us to evaluate it. All right, so first step, I'm just going to rewrite my stuff so it's x2 numeric powers. All right, so our basic rule for antiderivatives is our power rule backwards. So we add 1 and divide by it. So the 2 is a constant multiple. So we're just going to get that in our antiderivative. And then x to the third plus 1 will be 4. And I divide by it. Minus 6 times. Now I'm going to do x to the 1/2 plus 1 and divide by 1/2 plus 1. And then minus 2 times x to the -2 plus 1 is -1. So we get that. But we're missing one thing. Yep. So this is the part where you don't want to forget the plus c. Now, since we're actually going to have to do some calculations, I'm going to go ahead and clean it up. But like what the question asked, that is technically an answer. But if we go ahead and clean it up a little, that'll be x to the 4th over 2. 1/2 plus 1 is 3/2. So dividing by 3/2 will become multiplying by 2/3. So we are going to get -4, and then that'll be x to the 3/2. And then the -2 divided by -1 will become +2. And then x to the -1, you could leave it like that, or you can write over x and then plus c.
We left it at first where we still read it.
Mhm. Like it might be you stop here at the purple line and then your like start of B is to simplify it because B you're gonna have to put numbers in there. But yeah, I'm not gonna take off points if you don't simplify it in A. And I mean, you could even put the numbers into the purple formula. It's just a little uglier. But y'all got calculators to do the number crunching part, so. I would at least like to see, like, we know the integral from A to B of f of x dx is big F of B minus big F of A. So what we found up here was big F of x. So I would like to see that you understand, okay, this integral then is f of 4 minus f of 1. And now I'm going to plug 4 into that crazy formula. So we have 4 to the 4th power over 2 minus 4 times 4 to the 3/2 plus 2 over 4. And then when you're doing this, you don't have to put the c's because they will cancel out. Minus, and now we're going to do f of 1. 1 to the 4th power over 2 minus 4 times 1 to the 3/2 plus 2 over 1. Now, here, I'm okay if the next step is just number crunch, here's the answer.
Mhm.
4 to the 4th is 256, so half of that is 128. Minus square root of 4 is 2, 2 cubed is 8, 8 times 4 is 32. Plus a half, minus a half, minus 4 plus 2. All right, so this is 96 plus 4 minus 2, so it is 98. Because the positive 1/2 minus the 1/2 we got at the front of f of 1 would cancel each other out. But if you get some ugly decimal, that's fine. Just write me a couple of the decimal places and I'll be good. But this whole f of B minus f of A, you're gonna have to do that over and over and over again for like the first 2/3 of Cal 2. And then again, problem 8, not on this test. Like we could do it. Y'all are capable of doing it and understanding it. There's just no point in wasting the time on it. Okay. So I do want to point out one thing. I don't remember if we changed this or not, but like in the spring, he used the words, when is the ant moving faster? And I was like, what do you mean? Like, when is he moving the most positively, or when is his speed the fastest? So in the book made the distinction between speed versus velocity. Speed is the absolute value of velocity. So this one's B and C, asks you to figure out the velocity at 3 and then at 6 seconds. And I think at 3 seconds, the velocity is like 2. And then at 6 seconds, the velocity is like -6. So he's moving faster at t equals 6 because his speed is faster. Even though he's moving backwards faster than he was forwards. So I'm pretty sure we changed this wording to, when is the ant's speed faster? But if you're not sure what a question is asking on the test, just ask me. Like, we kind of write it communally and then we each take it and change the numbers and print it up. So typos do happen, but hopefully not. Hmm. Hmm. All right, so there are 8 questions on the final. I think we did a second application of the derivative instead of the substitution at the end. All right, so I will still be in my office for office hours today. Friday, there is no class. The math gym will also be closed on Friday, but they will be open next week. So you can still go in and get help, get them to help you run through any of the calculus concepts. And feel free to email me. I posted the announcement with the extra final exam time. So if you want to come Monday at 1, we'll be in here. And then Wednesday at 11, I'll be across the hall. So it's this room or the left one across the hall. It's in the announcements on campus.
Recently put in the grades and my grade went down to 6 points, even though I got the higher grade on the third exam. Then like I went from 100 to 90.
I think both of the exams were great, like the bonus and the regular. I'm about to pull up my paper.
Yeah, let me look.
Because it's like they have 200 and my grade took off.
Oh, yeah, I may have. Okay.
I was expecting my grade to go up, not go down, if that makes sense.
Yeah, no, it does. Yeah, I may have not put in the rules on the exams that I was supposed to. Like, normally we have a master copy of the course that has the gradebook all set up. And so we all just copy that in the rules copy, but that didn't happen because this is technically a new course. Hence also why we're not going all the way to substitution. So yeah, I just pretty sure I haven't programmed in any of the drops for the web work.
Yeah, because. Yeah.
Okay, I did the rule on exam 1, but I forgot to do it on exam 2 and exam 3.
Yeah.
Okay. My apologies on that.
That's okay.
Yeah.
Surprised because we were expecting it to go up and it went down.
No, thank you for asking.
Like, you still have both exams, like one is a bonus and one without,
Yeah.
and that like not that big.
Yeah, I gotta fix it. Okay. Right. Am I on this? Yeah, I'm on the assignments list. Why does it do this?
I was wondering if you handed out tests last class, because I wasn't here, so I was wondering if I could get it.
Yes. Okay. Hold on, let me just fix the exam.
Yes.
Because I found the right button, so now I'm like, no, I want to fix it where I know where the button is. There we go. Oh, let me stop the recording.